My hypothesized population proportion was 0.5. Divide this by the square root of p, hypothesized p, 0.5, times 1 minus p, divided by 559. And I'll race you. We'll see who can get this right. I got negative 2.83. Negative 66. The negative 2.83 was the right one. So everything on the top of the fraction, let's see. If you put everything on the top of the fraction in a single parentheses, you don't really have to worry about your fraction because order of operation will do that fraction first. And then you hit the divide, and then you hit the square root, and then you can just put 0.5 times 0.5 divided by 559. That follows order of operation. You should get the negative 2.83. Yeah, but you know that on your calculator, the square root automatically puts the parentheses for you. Yeah. So it it takes care of it, and it's all multiplication, so it's all going to follow correct order of operation anyway. TI-80, oh, doesn't give you the automatic parentheses? Yeah. Yeah. Okay. So what else do I need in a significance test? P-value.
Yes.
Okay. So I'm back to a normal distribution. So let me think of what my alternative hypothesis was a less than. So now we're going to be in a normal distribution. Let me mark that negative 2.83. My less than means that I should be looking at the left tail. So how are you going to get this p-value? Normal CDF from negative infinity to negative 2.83. No degrees of freedom because this is a normal distribution. We only need that for the t. So you would never write normal CDF, so maybe I'll just write it in a different color here. But the way you would get this would be normal CDF from negative 1 followed by a bunch of zeros to negative 2.83. Then I'll go back to writing in blue for my p-value. You can have a lot of p's being mentioned in the proportions test. Everything's going to kind of look the same. What are you getting for a p-value? .0023 was what I got. Okay. So now my step 4. Since my p-value is less than, I think I had an alpha of 0.05. Is less than 0.05. We can reject the null hypothesis. Yes, sir? Yeah, so finding critical value, that's called finding critical values. finding the cutoffs. Yes, you certainly may use that approach. There is nothing wrong with that approach. So since P is less than 0.05, we reject our null hypothesis. We can conclude, oops, let's write this right. That less than half of the population favors increased use in fossil fuels. If they understood what the question meant. I'm not sure that I understand it. Okay. So there's the significance test. The confidence interval that we learned before for proportions, we're going to review that right now. We're going to do a confidence interval with the same set of data. People say, oh, well, that tells you a little bit more. It doesn't just tell you that less than half of the people favors this increase in fossil fuel. It'll tell you approximately what proportion favors the increased use in fossil fuels. So let's go back and do a confidence interval on the same set of data, just to see what else we can get. So let's do a 95% confidence interval. And we don't get that strict relationship of 95% confidence being the same as 5% significance test. It's close, but not exactly the same. So we don't play that game that we had to play last chapter with comparing the confidence interval to the a significance test when we're doing it for a mean. But let's just make a confidence interval here. And I'm going to make one from scratch because there are a few things we got to do differently. Step 1, we're going to estimate the proportion of the population who favors increase fossil fuels. Step 2, we're doing a confidence interval for a population proportion with a normal distribution, single sample. Our conditions are not quite the same. SRS, yeah, we had that. Normality. For my normality check for a confidence interval, we use p hat times n. And n times 1 minus p hat. Okay? I said sure. So it's still got to be greater than or equal to 10, but we're not using 0.5. So our n was 559, but our sample proportion of, how much was it? 246 out of 559. Times the 559 is 246, which is greater than or equal to 10. And what's 559 minus 246? 313 is also greater than or equal to 10. But that check is just a little bit different. Let me scroll back. When we did the check before, we did 279.5 greater than or equal to 10. Rather than 246 and 313 greater than or equal to 10. Okay? And independence, our population needs to be greater than 5,590 again. My confidence interval is the sample proportion